Welcome to this lesson on Introduction to Three-Dimensional Shapes. First, we're going to go over the vocabulary of what makes a three-dimensional shape and all the different pieces. So a three-dimensional shape is a figure that does not lie in a plane and has three dimensions: length, width, and height. Right, so here you have your example of a three-dimensional figure. It cannot lie in one plane because of the fact that it has that height to it, or some people will call it depth. So that's why it does not lie in one plane or in a plane. All right, then the faces. The faces of a three-dimensional figure are the flat surfaces of the 3D shape. Right, so not all 3D shapes have faces because they have to be flat. In this case, the face would be the top up here, or any of these sides that you see here and in the back. And then also the bottom. Those are called the faces because they're all flat. There's no curve to them. Edges. Edges are segments where two faces meet. So your edge is going to be basically where those connecting pieces would be. So like if you were to actually glue it together, it would be where you would have to glue to put the panels and top and bottom in place. You can also look at an edge as, if you look at this as just a rectangle, the sides all have to connect to another shape at some point, so each of them is going to be an edge. A vertex is a point where three or more edges meet. Okay, a vertex is kind of your fancy word for corner. We've heard about vertexes with angles. Now here, there's going to be more than 2 points meeting because you have that depth to it. So the vertex is where three or more edges meet. So that corner right there, here, 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 down on the bottom. Now you have to remember there's vertices in the back that you can't see that also need to be counted. So you have to kind of keep in mind what kind of shape you're working with, and we'll talk about that on the next page. All right, so when you're looking at how many faces you have, one of the things you want to look at is the base of your shape. In this case, the base of my shape looks to be a rectangle, so here's my base. Now I know that my base has four sides, 1, 2, 3, 4. Because of that, I know that in order to connect to the other base, it has to have another face coming off of each side. So if my base has four sides, that means that this middle part has to have four faces. So there's four faces here connecting the floor to the roof, so to speak. So you have four here, and then you have your floor and you have your roof. So you have 6 faces. Now vertices, again, you can look at your base and you see that you have 1, 2, 3, 4 vertices here. Well, there's not going to be anything in this middle part right here. So if you have 4 on the bottom and you're working with a prism, then you should have 4 on the top. Prism is basically where your top and your bottom match, and we'll go over that definition in a little bit. So if I have 4 down here, then I have to have 4 up here. So in this case, I have 8 vertices. And then the sides of my base can also help me with the edges. So I have 4 edges on my base. So that means I have to have 4 edges to connect my base to my roof. And then I have to have 4 edges on that base part. So if it's 4, 4, and 4, I know that that's 4 times 3, which is 12. Again, as you start to work on this more, you'll start to see those patterns. All right, now in this case, you have to be careful. You have to determine whether or not this is a pyramid or a prism. In this case, we are working with a triangular prism. So this point at the top is not where all of the faces meet. There's actually a line, and then back here, so you have to kind of imagine that this is a line here, and then there's lines here, creating your triangular prism. All right, so now since your base is a triangle, you have 3 sides, so you know that you have a top and a bottom, so that's 2. And then since you have 3 sides, you have to have 3 faces connecting all those. So you have 5 faces. For your edges, okay, so you have the 3 edges here, you have the 3 edges in the back, and then you have the 3 edges on the side, so you have 9 edges. For your vertices, there's going to be 1, 2, 3 on this side, on the top, and then on the bottom there's also going to be another 3. So that gives you a total of 6. Again, this one is kind of tough with the way that the shape looks because it looks more like a pyramid. So this is where you actually have to get kind of good with your imagination to be able to see those lines or put them in there yourself. All right, so we talked about a prism, and this is where your definitions are really going to come into play. So a prism is a 3D figure with 2 parallel and congruent bases. Parallel meaning, so it's like the floor of your house and the ceiling of your house. They're never going to touch because they're parallel. So think of a 3D shape as a home. Those 2 bases that you see are never going to touch, and they are congruent because in order to cover up the entire shape, you have to put a shape on top that is the same size. And then all the faces are polygons. In order for it to be a prism, all the faces have to be polygons, which means they can't curve, they have to be closed, and they have to have at least 3 line segments. Okay, so here we gave you some examples. Now this right here, this would be your base. So in this case, it has 6 sides, so it's a hexagon. So we call it a hexagonal prism. So now you know here's the top, then on the bottom is another hexagon, and then to connect that top and bottom hexagon, you have the walls. So you'd have to have 6 walls to connect those 6 sides. A cube, we're really good with cubes. A cube is a 3D figure with all congruent faces. So in order for it to have all congruent faces, you know that all the faces have to be squares. So this is a cube. Pyramids. Pyramids are 3D figures with 1 polygon base and all the other faces are triangles. Now when we look at pyramids, typically we think of the pyramids in Egypt that have a square for a base and then triangular sides. Now you can have different types of pyramids. So here's an example of one where you have a square base and then it all meets at 1 point. So this 1 point meeting up at 1 point at the top is what makes it a pyramid. Right, so then now to name your pyramid, you name it based on its base. So since this is a square, we would name this a square pyramid. Here it meets at 1 point, making it a pyramid, but its base, you can see, is a triangle. So since it's a triangle, you know that the name of this is a triangular pyramid. And you can have hexagons, heptagons, you can have all different kinds of pyramids, as long as they all meet at 1 point, so there's not a matching ceiling to the floor. It makes it a pyramid because it all connects right here. A cylinder. A cylinder is much like a prism in the fact that it has 2 bases that are parallel and congruent. However, those bases are circles. So since the bases are circles, they're not polygons. Okay, and we know what cylinders look like. You've heard about these before. It's just a reminder that it is not the same thing as a prism because it has these curved sides. Now if you look at a cylinder, it has 2 faces because this face up here is flat and down here is flat. But this isn't a face because it's not flat. Cones. We're really good with cones. We know a cone is a 3D figure with 1 circular base and 1 vertex. So a cone is kind of like a pyramid with a circular base. Right? All of these would be cones. It meets at the point right up here, and then the base is a circle. So basically, if it looks like you could eat ice cream out of it, it's your cone. Alright, so you're going to try, I want you to determine how many faces, edges, and vertices the 3D shape has, and then name it. So you have all these different choices here. So determine the number of faces, edges, and vertices, and then name it. So don't forget, you have to decide. What I would suggest doing is decide first, is it a prism, pyramid, or other? Because then you know if it's a prism, then you name it for its base, so it would have to be, a hexagonal prism or a hexagonal pyramid. If it's other, that means that it's going to be a cylinder or a cone for you. Those are the only other two that I want you to be able to know by name, but you need to know that they don't fit in the realm of prism or pyramid. Okay. Take your time with these. Really think about what makes each shape and use your definitions to help you with that. And as always, if you have any questions, please be sure to email me or write them down so we can go over them in class.